In this video, I will be teaching step-by-step how to do PCC load balancing for two internet lines of the same speed, plus failover, on a MikroTik router with Router OS version 7. Load balancing in data networks means equitably distributing the connections or traffic of my clients across the number of links or internet providers I have. Load balancing is a special configuration applied on MikroTik routers to route all connections entering through the interface labeled as LAN to be distributed equitably through the WAN 1 port and the WAN 2 port. What I mean by this is that, if 100 connections enter through the LAN port, approximately 50 connections will be routed through WAN 1, and 50 connections will be routed through WAN 2. This way we avoid bottlenecks in our network traffic. In this lab, we have Internet Provider A, with the IP address 192.168.1.1, and Provider B, with the IP address 192.168.2.1. Notice that the IP address ranges of the provider's networks are different. The provider's routers will be connected by a cable to the MikroTik, and the IP addresses have a consecutive order. For Provider A, 192.168.1.1, and the MikroTik port receiving that connection will have 192.168.1.2. For Provider B, it will have the IP address 192.168.2.1, and the MikroTik port receiving that connection will have 192.168.2.2. The computer connected to port 5 of the MikroTik will have the IP address 192.168.5.2. The network ranges of the internet providers and the LAN network must be different for the load balancing implementation to work well. I'm Richard Reyes, CEO of Enlinkit. Let's begin. We'll start the configuration by logging into the MikroTik. And then we assign it a new password, in this case 1234, and confirm the password. Now we are going to configure a name for our router. We will call it Enlinkit. To perform the load balancing configuration on this MikroTik router, I have tried to divide this into 9 fundamental steps. So let's start with step number 1, which will be configuring the bridge for the LAN network. We are going to create a bridge. We will call it LAN. And in ports, we will add the ports that belong to this LAN network. It will be Ether 3, Ether 4, and Ether 5. Here we experience a disconnection from Winbox, and adding this port 5 to the bridge, the disconnection is normal, but we will log in again. Password 1234, I click connect. We close this window. Step number 2 consists of labeling the interfaces of our router. For this, we go to Interfaces, and we are going to label Ether 1. We will label it as Ether1_WAN1. Click OK. Ether 2 will remain Ether2_WAN2. And finally, Ether 5 we leave as Ether5_PC. since my computer will be connected to this port. Step number 3 will be assigning IP addresses to the interfaces according to our network topology. So we go to IP addresses and start with the IP address of the Ether1_WAN1 interface. Now we configure the IP address of Ether2_WAN2. And finally, we configure the IP address of the LAN network. Step number 4 we will do based on the networks of the IP addresses we created in the previous step. For this we go to IP, firewall address list. We click on the plus sign. In list we will create a new IP address list called redis_WAN, which stands for WAN networks, and we will copy the network of WAN1 and paste it where it says address and add the /24. Click OK. We repeat the process to add the WAN2 network to the redis_WAN list. OK. Now we click on the plus sign to create a new list called redis_LAN, which stands for LAN networks, and we copy the LAN network, paste it and add /24. OK. And we close the IP addresses window as we don't need it for now. We will maximize our firewall window and continue with step 5, create the NAT for the WAN interfaces. I click on the plus sign, General tab, Chain, srcNAT, Out interface. I select Ether1_WAN1. Action masquerade. Click OK. And now I will do NAT on the Ether2_WAN2 interface. Very well, we close this window and continue with step 6, which will be creating the routing marks. For this we go to routing table. I click on the plus sign, name to WAN1, and the FIB must remain enabled. OK. And now I will add the routing mark to WAN2. I enable the FIB, and OK. Now we continue with step 7, which is adding the DNS. We go to IP DNS, and in servers I add 1.1.1.1 from Cloudflare 8.8.8.8 from Google. Click OK. Step 8. This step is the longest as we will work in IP firewall mangle. In this mangle, it is crucial that we pay close attention to every detail we include, since everything we do here will be used later in the routing marks. So the objective of this video is to teach you step by step how to configure your load balancing, meaning that the connections entering through the LAN interface are distributed equitably between WAN 1 and WAN 2, but the traffic directed between LAN networks, we don't want it to be balanced. For example, if I want to access a client's radio or ONU from a PC on the LAN network to manage it, that traffic should not be balanced, and that will be the principle of our configuration here in the mangle. So I click on the plus sign, General tab, Chain, Pre-routing SRC address list, I select redis_LAN. Then in DST address list I select redis_LAN as well. In the Action tab we will leave it as accept. And add the comment no balanzo tráfico entre redes LAN. Don't balance traffic between LAN networks. This will allow us to manage our equipment without any difficulty. The next rule we will implement serves to allow management of our provider's routers from a PC on our LAN network to be able to access them and make changes or view network parameters. So in this case, for simplicity in the topology, I drew a cloud, but really our node, usually the provider connects us to their network through a router or an ONU or a radio. So the following rule will allow us to manage those provider devices. We click the plus, chain pre-routing, DST address list. We select redis_WAN. In Action, we leave it as accept, and let's see the comment. Acceso a routers de proveedores de internet, access to internet provider routers. Okay. We continue, we click the plus. And this rule we will work on in the input chain, meaning everything directed to this MikroTik router that enters through the Ether 1 WAN 1 interface. In Action, we will mark that connection as WAN 1 CON and leave pass-through enabled. Then in comment, we write input, OK and OK. To better visualize the rules we are creating, let's go to Show Columns and uncheck DST address. Because we are not using it, and also uncheck SRC address, click OK, and that's better. Now we are going to copy this input rule we made for Ether 1 WAN 1 and change the interface to Ether 2 WAN 2. And in the Action tab, the connection mark will be WAN 2 CON. And we delete the comment as we don't need it. Click OK. The next rule consists of marking connections originating from the internet in such a way that what enters the MikroTik router through one WAN interface exits through the same one. So I click the plus, General tab, Chain Pre-routing, Interface Ether 1 WAN 1, Connection mark no mark. This is very important that the connection does not come marked, as the router doesn't know the connection yet, because this connection originates from the internet, and what we want to do is precisely identify it with this mark. Then in the Action tab, we select Mark Connection, New Connection mark WAN 1 con, and leave pass-through enabled, as we want the sequence to continue after the mark is applied. Let's add a comment, connection marking for WANs. Click OK. And now we will simply copy this rule to edit it. But regarding Ether 2, WAN 2. In Action, the connection mark will be WAN 2 con, and I will delete the comment. Click OK. The next rule will be in the output chain, which means that everything leaving or originating from the MikroTik router that has the connection mark WAN 1 con. In the Action tab, we will put a routing mark, which will be to underscore WAN 1, and we uncheck pass-through, since only up to here, that chain ends with the routing mark, which is the final goal. And we add a comment, output. Click OK and OK. Now we copy this rule and we will edit it, but in relation to WAN 2. And we add the new routing mark to underscore WAN 2. We will delete the comment OK. The next rule will be the start of PCC. PCC is the algorithm we will use in this configuration, but we won't go into detail on how this algorithm works for time reasons, but I will show you in a simple way how to implement it. So I click the plus. General tab, Chain Pre-routing. In Interface LAN, connection mark, no mark. In the Advanced tab, in Per Connection Classifier, we select both addresses, and here we write the number 2. 2 because we are balancing 2 internet links. If it were n links, the number would be n, and the index starts at 0. So we leave it as is. Then in the Extra tab, we select DST, address type local, but we check the checkbox with the exclamation mark. Since all these orders we are giving to the MikroTik in this rule, we want them to work for the entire network. But regarding local traffic between LAN networks, do not apply those policies. Now let's go to the Action tab, and we will mark the connection. and this mark will be WAN 1 con, pass-through remains enabled. And in comment we write PCC, since this is the beginning. Click OK. Now I copy this first PCC rule and I will edit it. In the General tab, everything remains the same. Then in the Advanced tab, in Per Connection Classifier, both addresses remains the same. 2 remains the same since we are still balancing 2 internet links, and the index we leave at 1 since the previous one was 0. In the Extra tab, we make no changes. But in Action, we will change the name of the connection mark. Here we select WAN 2 con, and we will delete the comment. Click OK. All that remains is to make the routing marks for the connections we marked a moment ago, and that also enter through the LAN interface. So we click the plus, General tab, Chain Pre-routing, in Interface LAN, connection mark, we select WAN 1 con, and in the Action tab, we select Mark Routing, and in New Routing Mark, we select to underscore WAN 1, and we uncheck Pass-Through. In comment, we will write routing marks. Click OK. Then we will copy this rule and edit it with the connection mark WAN 2 con. And in the Action tab, the routing mark will be to underscore WAN 2, and we will delete the comment. Click OK. Very well, friends. This way we have finished the mangle configuration. In total there are 12 rules, and we will continue. Step 9 will be the creation of static routes, including failover. Let's take a look at our network topology to be clear on what we are going to do. Remember that WAN 1 has the gateway IP address 192.168.1.1, and WAN 2 has the gateway IP address 192.168.2.1. It is important to keep these in mind to avoid errors later. Additionally, we will work on failover using recursive routes. Usually this is done by choosing reliable DNS servers. These DNS must be different from the DNS we already used in step 7. This is a very important point. Basically, what we aim for is that the MikroTik's test to check if the WAN 1 or WAN 2 link is connected to the internet is done precisely to an IP address of a server on the internet or a reliable DNS, and not perform these tests locally. We do this because the provider's router or the ONU might respond locally, but it could be the case that there are failures further back in their network. So, to be sure, we will not use the local IP addresses of the routers or ONUs or radios of our internet providers, but we will use external DNS, and with this we guarantee internet service to the clients in such a way that if WAN 1 were to fail, that route would be temporarily deactivated automatically, and the traffic entering through our LAN network would not follow that route but would follow the WAN 2 route. Similarly, if WAN 2 were to fail, that route would be temporarily deactivated automatically, and the traffic entering through our LAN network would not follow that route, but would follow the WAN 1 route. This way we ensure that our clients are always connected to the internet, providing optimal service availability. So, based on what was said earlier, we will establish the DNS we will use for our failover. For WAN 1, which has the default route 192.168.1.1, we will use Google's DNS 8.8.4.4, and for WAN 2, which has the default route 192.168.2.1, we will use OpenDNS's DNS 208.67.220.220. Let's start with the configurations. We go to IP, routes, click the plus, and this route will be the test route for WAN 1. So in DST address we write 8.8.4.4, meaning reach that Google DNS via the gateway 192.168.1.1, which is the gateway for WAN 1. We will leave the scope at 10 and add a comment, route a recursive WAN 1. OK. And we will repeat the process with the recursive route for WAN 2. In DST address we write 208.67.220.220. In gateway 192.168.2.1, we will leave the scope at 10, and the comment will be recursive route WAN 2. Click OK. Now we will work on adding the rule for the main route of WAN 1. So we click the plus. The gateway will be 8.8.4.4. Check gateway ping distance 1, and the target scope will be 11. This target scope value is one of the main changes MikroTik made when moving from Router OS version 6 to version 7, as it is mandatory that this target scope be greater than the scope we used in the routes configured moments ago. So we add a comment, WAN 1 route, and OK. Now we will configure the main route for WAN 2. Gateway 208.67.220.220. Check gateway ping, distance 2. Target scope 11. Comment route of main, WAN 2. Click OK. And thus we have finished configuring our two main routes, one with distance 1 and the other with distance 2. If I enter the main route for WAN 1, observe that the immediate gateway is 192.168.1.1, and the main route for WAN 2 is blue. This is because the distance is 2, and the immediate gateway is 192.168.2.1. Very well. Now we will configure the rules for the routing marks to underscore WAN 1. Click the plus. Gateway 8.8.4.4. Check gateway ping, distance 1. target scope 11, routing table select to underscore WAN 1. And we will add the comment route to WAN 1. Click OK. If I enter the route I just created, observe that the immediate gateway is WAN 1. So this is very important to review and ensure the rule is well made. That is, if this is a main route it has distance 1, and we ensure the gateway is the desired one. So this is correct, and we will continue creating the backup route for everything with the routing mark to underscore WAN 1. I click the plus, the gateway will be 208.67.220.220, check gateway ping. The distance will be 2, as this is the backup route. The target scope 11, and in routing table we select to underscore WAN 1. In comments it will be backup route to WAN 1. Here we can infer that this route is a backup because the distance is 2, and the immediate gateway will be WAN 2. Observe, these are the two routes we have created for everything with the routing mark to underscore WAN 1. The one in black is the main route with distance 1, and the one in blue is the backup route with distance 2. So, let's now create the rules for everything that has the routing mark to underscore WAN 2. Click the plus, and the gateway will be 208.67.220.220. Check gateway ping, distance 1, target scope 11. And for routing table, select to underscore WAN 2. Comments, route to WAN 2. I click OK, apply, and OK. Now we will create the backup route. Click the plus. Gateway 8.8.4.4, check gateway ping, distance 2, target scope 11, and the routing table will be to underscore WAN 2. Backup route to WAN 2. Click OK. Then I click apply and OK. Observe, these are the two routes we have created for everything that has the routing mark to underscore WAN 2. We have the route with distance 1 in black letters, and the backup route with distance 2 in blue letters. This means that if the route with distance 1 fails for any reason, then the route with distance 2 will automatically activate and overflow all traffic through that internet link. And this simply serves so that our clients always have internet service available. Very well, we have finished this part. Now what follows will be to perform tests and validate that the traffic entering through our LAN interface is routed equitably between WAN 1 and WAN 2, so that we can use these two internet links simultaneously. But I must configure the IP address on my computer according to our LAN network segment. So we enter the network card settings of my PC and configure the IP address 192.168.5.2, the netmask 255.255.255.0, the default gateway 192.168.5.1. For the DNS, I will use the same ones I put in step 7 in the MikroTik configuration. If you remember correctly, the preferred was 1.1.1.1 and the alternative 8.8.8.8. I click OK. Observe that at this moment there is no significant traffic on my WAN interfaces, but let's verify that our PC already has internet. Let's perform a speed test. And here you can see that the traffic entering through the LAN network is distributed through WAN 1 and also through WAN 2, which indicates that the configuration is working well. Let's validate the upload traffic, and as you can see, it is also being distributed through WAN 1 and WAN 2. We can also see how browsing flows on other web pages. The MikroTik page works well. My website and linkit.com is working well. Remember that if you need any type of configuration, you can contact me. Now what I would like to do is a speed test. But this time with speed test. Let's click go, and here we can see that the download works well. It distributes the traffic very evenly between WAN 1 and WAN 2. But the upload is not managing very well. This is because this application works with specific ports, specifically 8080. For now, with what we have so far, the configuration would be finished. And with real client traffic, you could see this very homogeneous between WAN 1 and WAN 2. But if you want to improve the speed test a bit, we could do something here, and that is to go to the mangle to make a modification in the PCC rules. But before that, observe that the 12 rules we have in the mangle all show packet movement, and that is a good sign. Very well, let's modify the 2 PCC rules to optimize the speed test. I click on the first PCC rule, and in the Advanced tab and Per Connection classifier, I will change it to both addresses and ports. I click OK. And now we also edit the second PCC rule. Change the classifier to both addresses and ports. And click OK. Now let's perform the speed test again. And observe the download working like clockwork, very neat. And in the upload we can see how our test improved considerably, injecting the traffic distributed across WAN 1 and WAN 2. As you can see, it's working perfectly. Now to finish, the following tests will help us evaluate how our MikroTik works in case of failures in WAN 1 or WAN 2. We will be able to evaluate the response time and, above all, verify that we meet our objective, which is that our clients never lose internet service. So, to do these tests, we have the interfaces window here, and the routes window all simultaneously to analyze the behavior of our router live in case of any failure. So initially, observe that this route with the comment route to WAN 1 is the one that allows traffic to flow in the direction of that Ether WAN 1 interface. The route is active as you can see there, but I'm going to remove the fiber optic cable that feeds that WAN 1 router from my provider so we can analyze what happens. So right at this moment, I disconnected the cable, and as you can observe, in very few seconds, the MikroTik already detected that something is wrong with WAN 1 and presents the route as unreachable. But we don't have to worry because for these emergencies we have our backup route to WAN 1, which is this route with distance 2. So that my clients should always remain connected to the internet. If I restart the speed test, you can observe that the internet service has no interruptions, as the traffic is being automatically routed through the only WAN we have in service at this moment, which is WAN 2. Let's show browsing through web pages, and we find that this is working perfectly, the failover. Now I will normalize the internet service on WAN 1. And observe that the route has changed its state again. Now it is active. And if I repeat the speed test, we find that traffic is already being distributed through WAN 1 and WAN 2 equitably, just as it was before the failure. Now let's evaluate how the failover is working for WAN 2. Observe that the route looks active. And right at this moment, I am going to cut the internet to WAN 2. Here we can see that the MikroTik, in less than 4 seconds, detected that something was wrong with WAN 2 and automatically deactivated the route. Observe that it is now unreachable. But again, we don't have to worry, as we have the backup route for WAN 2 working. And if I run the speed test, it works correctly, sending traffic through WAN 1. If I test browsing, everything continues without any failure. This means our failover is working correctly for both WAN 1 and WAN 2. So I will restore the internet connection for WAN 2. And the route looks active again. Very well, friends. This is the most efficient way I have found to do PCC load balancing for 2 internet lines of the same speed on a MikroTik router, including failover, all in RouterOS version 7. I know it's a lot of content, and perhaps doing this step by step can be exhausting. That's why I will make a new video where I will explain how to download the script with the current configuration so you can implement your load balancing in less than 5 minutes, just by copying and pasting the commands into your MikroTik console. I hope all this explanation has been helpful to you, and see you soon. Remember to like this video and share it.